Hello and welcome everybody. This is Professor Rajesh Barapate, a book author of 25 plus engineering books. In today's video, I will explain the concept of superposition theorem. I will be teaching some simplified techniques to solve numericals based on superposition theorem. Let us first discuss the statement of this theorem. In any linear bilateral network containing two or more energy sources. Now, meaning of energy sources is either it is a current source or voltage source. Then the voltage or current of any branch is algebraic summation of voltage or current produced by individual sources acting alone. See, we'll solve few numericals, then this statement will be more clear to you. Important part is that what we have written, you will have to consider one source at a time. Whereas what to do for remaining sources, if remaining source is a voltage source, then short circuit it, and if remaining source is a current source, then open circuit that. We need two important formulae to solve the numericals. One is well-known Ohm's law, current I is equals to voltage upon resistance, and second we need to make use of current division formula. It's very simple. Current in any branch is equals to supply current, that is main current, into opposite resistance divided by addition of resistance. We'll solve the numericals, then this concept will be more clear to you. Consider a problem. The given question is calculate current through 3 ohm resistance using superposition theorem. This is the given network. Now, there are two sources in the given network. One is 10 volt. It is voltage source. Another is 1 ampere. It is current source. This is 2 ohm resistance and this is 3 ohm resistance. I have to calculate current passing through 3 ohm resistance. I will give some names like AB. That means I have to calculate current flowing through branch AB. Now step 1. There are two energy sources. One is voltage source, another is current source. At a time, consider only one source. So you can consider any source at a time. So first I will consider 10 volt source. If I am considering 10 volt source, think about the rule. Remaining source is current source, that is 1 ampere. What we have written, only two rules you will have to apply. If remaining source is voltage source, short circuit that branch. If remaining source is current source, open circuit that branch. So I am considering 10 volt voltage source. Remaining source is 1 ampere. I need to open circuit it. Open circuit it means simply we need to draw the new diagram like this. Just cut the wire from this branch and it will represent the open circuit. Now, using any method, you are supposed to calculate current passing through AB. Let us denote this current by I1. Since it is the current of stage 1, I am using the notation I1. Now the network is pretty simple. One voltage source is there and two resistances are there, one after the other. These two resistors are said to be in series. Very simple trick. If resistors are connected one after other in a same wire, they are said to be in series. So these two resistors are in series. So resistance becomes 2 plus 3, that is equals to 5 ohm. This is the value of total resistance in the circuit. I need to calculate current I1, make use of Ohm's law. What is the basic Ohm's law? I is equals to V upon R. What is available voltage in the diagram? 10 volt. So I will write this current as I1 is equals to available voltage, that is 10 divided by total resistance. Don't make a mistake. Even if this I1 I have shown in the diagram, it is flowing to 3 ohm. Same current I1 comes out from 10 volt and passes through this wire. That means we need to add these two resistances. Only 3 ohm is not sufficient. So I will write this as 5. So this answer is 2 amperes. This is the answer of first stage. Now the second step. What we did in first step, we considered only 10 volt source. So we open circuited the remaining source, that was current source. In step 2, consider the remaining source, that is, I will write like this, consider 1 ampere source only. If I am considering this source, what are remaining sources? Remaining source is only one, that is 10 volt. Recall the rules, what we have written. If remaining source is a voltage source, short circuit that branch. Short circuit means simply remove that source and connect a wire. This is called as a short circuit. Simply join it by a single wire. So this is the a circuit for step 2 when we consider only 1 ampere current. Now, as I mentioned earlier, there is no restriction. You can apply any technique. Our aim is to calculate current passing through this branch AB. I will denote this current by notation I2 since it is the current we are calculating for step 2. A simple technique I will tell you. Simplest method is use a current division formula. See, I am interested in calculating current I2. Look at this current source. This is 1 ampere current source. It comes at this point up to this point. After this point, some current from 1 ampere is passing through this branch. This current is I2. And some current, remaining current is passing through 2 ohm. What I am interested in? I am interested in calculating this value of I2. So this current source I1 is getting divided into 2 branches because after this current source, 2 branches are connected. I need to calculate the current I2. So I am using current division formula. This is most important formula. Do remember it. Current in any branch. Any branch means I want to calculate current I2. So I will write over here I2 is equals to supply current. Which current is getting divided? 1 ampere current. This is supply current. So it is 1 into opposite resistance. This is supply current which I considered. Then opposite resistance. Opposite resistance means there are 2 resistors. I am calculating current passing through 3 ohm except 3 ohm. What is remaining resistance? That is the opposite resistance. That is 2 ohm. So I will put value 2 divided by addition of resistances. What are the total resistances available in the circuit? 2 ohm and 3 ohm. So it is 2 plus 3. Pretty simple. So you just have to do this calculation. So this becomes 2 by 5 amperes. Since it is current, I am denoting it by amperes. Now, this is 2 by 5 amperes means 0.4 ampere. I am using downward arrow. In the exam, you are supposed to mark the direction of arrow. In the first step, I have calculated I1. That time also the current was moving downward, so I have marked the arrow like this. Now, this is step 2. Step 3. Step 3 is very straightforward. In step 3, what we are supposed to do? Just add the answers we calculated in step 1 and step 2. So, final answer is I, that is current, is equals to, you can well write this as IAB, current passing through branch AB, is equals to I1 plus I2. So, simple addition of these 2 currents, that is 2 amperes. Here I have you marked a downward arrow plus 0.4 amperes. Again downward arrow. Keep in mind, while adding, since both the currents are moving in downward direction, they are in same direction, I am directly adding it. If suppose 0.4 would have been moving in upward direction, I would have subtracted it from 2 ohm. Let us discuss this concept in the next numerical. Presently, both currents are moving in downward direction. So simple addition, final answer becomes 2.4 amperes, arrow is downward. This is the final answer. We calculated current passing through 3 ohm using superposition theorem. Next problem is calculate current through 8 ohm resistance using superposition theorem. Now, there are again 2 sources. One is current source of value 20 amperes, another is voltage source of value 5 volt. It is asked to calculate current flowing through 8 ohm resistance. So I will give some notations like AB. It is asked to calculate current passing through branch AB, that is through 8 ohm resistance. Like the previous sum, at a time we will be considering one voltage sources. So step 1, consider 5 volt source. You can well consider 20 amperes at the beginning, no issues. So presently I am considering 5 volt source. What is the remaining source? It is a current source. In the last sum itself we discussed, if remaining source is current source, open circuit it. Open circuit it means simply cut that wire, so it will represent open circuit. Do remember the basic points. When we say it is an open circuit, current is not flowing through this branch. That means there is no current passing through this element. So I'm considering 5 volt source only. This is the remaining diagram. There are various methods how to calculate the current passing through 8 ohm method. I will tell you simple technique. We'll calculate what is the total resistance of the circuit. How to do it? See, this is open circuited. As I said, due to open circuit, no current will flow through this. Now look at these two resistances, 12 ohm and 8 ohm. They are in the same wire. Keep in mind, this is open circuit. That means current is not flowing through this branch. That means as if this branch is not connected. So 8 ohm and 12 ohm are in series. How you identified? They are in the same wire, because there is, even if we have drawn the wire, current is not flowing through this branch. So 12 ohm and 8 ohm are in series. So this can be written as 12 plus 8, that is equals to 20 ohm. Now how to draw the resultant diagram? After taking this in a series combination, remove any one of the resistance. Let us say I have removed this resistance. For the remaining resistance, write down the resultant value, that is 20 ohm. What we did, first we considered 12 and 8 ohm in series. Now one simple technique I will tell you. Such type of networks are called as ladder networks. Apart from the name of this network, if first combination is series, next will be in parallel, again next will be in series. It is always alternative. If first combination is in series, second will be in parallel, third will be in series, and so on. On the contrary, if first combination is in parallel, second will be series, third will be parallel, and so on. We have considered first combination as series, and then I have drawn this diagram. Now next two resistances are remaining. These two are in parallel. You don't have to even think whether they are in same branch or opposite branch. First was in series, so second I will consider it in parallel. So I will write this as RT. RT is total resistance. RT, total resistance, which is 20 parallel 30. I hope you are aware how to do this calculation. It is simply multiplication, that is 20 into 30, divided by addition, that is 20 plus 30. So this value of total resistance will be 600 upon 50, that is equals to 12 ohm. This is the value of total resistance which I calculated. Now I need to calculate total current. Do remember, in the present diagram, only one source is present now. So whatever current is coming out from this source, I will denote it by IT. IT stands for total current. Again, make use of Ohm's law. I is equals to V upon R. So in this case, I will say IT is equals to V. What is the available voltage source? 5 volt. So I will write it as 5 divided by, what is the total resistance? That is 12. So 5 by 12 will give you the value of total current, that is 0.41 amperes. So 0.41 amperes, to be more precise, it is 0.4167 amperes is the total current coming out from the 5 ohm source. Now see, this total current is same as this branch current. That means this current is again IT. What I am interested in? I am interested in calculating current through this branch AB. Due to open circuit, whatever current is passing through this, same current will flow through this 20 ohm. I will denote this current by I1, simply because this is the current of stage 1. Or to avoid the confusion, you may consider or redraw the original circuit, just to avoid the confusion. This resistance was 12 ohm and this was 8 ohm. Now consider like this. Suppose this current which is flowing through 8 ohm is I1. It is denoted by I1. I have already calculated total current. Total current is this current, IT. After this point, current gets divided. Some current is flowing in forward direction, that is denoted by I1. Remaining current is passing through 30 ohm resistance, this current. But I am not interested in this current. What I am interested in, I want to calculate current I1. Again, make use of the current division formula. So how to make use of current division formula? current in any branch, that means I want I1 is equals to supply current. Supply current in this case is total current. So in terms of notation, first I will write IT into opposite resistance. See, I am calculating current I1, same current is passing through 12 ohm. So irrespective of this branch, I am calculating current passing through this branch. Apart from this branch, what is the remaining branch? That is 30 ohm, that is called as opposite resistance. So I will write it as 30 ohm divided by addition of all the resistance. So it is 12 plus 8 plus 30. Now I will simply put the value of IT, that is 0.4167 into 30 divided by 12 plus 8 plus 30. You need to do this calculation on the calculator. So after completion of this calculation, answer will be 0.25 ampere. This is answer of first step. How to show the direction? Look at the diagram. Current I1 I have shown from RHS to LHS like this. So I will mark the arrow inside the bracket like this, because current is flowing from RHS to LHS. So answer of first stage is I1 is 0.25 amperes. Arrow is like this. The second step is we have to consider the second source, that is 20 ampere source. Do remember earlier we considered 5 volt. Now we are considering 20 ampere source. This is the current source. Apart from this current source, what is remaining source in the circuit? It is 5 volt. It is a voltage source. What we learned, if remaining source is voltage source, short circuit that branch. That means simply I will have to remove this 5 volt and I need to draw one branch, one wire over here. This is denoted by SC, short circuit branch, short circuit branch. Now one very important concept. Do remember throughout the calculation, if short circuit is there in parallel with any branch, then that branch will become inactive. I will repeat. This is 30 ohm resistance. There is a parallel branch which is simply wire. No resistance is over there. This is called as a short circuit. The tendency of current is always flow through the path which is having minimum resistance. Short circuit is zero resistance. So whatever current is flowing, entire current will pass through this short circuit branch. No current will pass through the earlier branch, that is through 3 ohm. So how to memorize it? How to remember it? Very simple. If there is a short circuit in parallel with any branch, remove that branch. That branch is called as redundant branch. Means it is present in the network, but no current is flowing through that branch. So it is of no use. So for the simplicity, just remove this branch. Remove this 30 ohm resistance. Now this is the resultant circuit. Now the calculations are pretty simple, but avoid the common mistake. Keep in mind the concept of redundant branch. Whenever there is a short circuit in parallel with any resistance, remove that resistance because it becomes redundant. Now remaining calculation. I am supposed to calculate current passing through 8 ohm. Let us denote this current by I2. Question arises, why have marked the arrow like this? Very simple. Now in the remaining circuit, only one source is remaining. Look at the direction of 20 amperes. It is given in the question like this. So through this branch, 20 amperes is flowing like this. At this point A, division of current takes place because after A, 2 branches are there. Some current is flowing through 12 ohm. Remaining current is passing through AB branch. So naturally current is flowing in this direction because it is coming from a 20 ampere source like this. What I am interested in? I am interested in calculation of value of I2. So how to do this calculation? Again, we are supposed to make use of current division formula. Current in any branch. I want to calculate current I2 is equals to supply current. What is the supply current in the present case? It is 20 amperes. So I will write 20 into opposite resistance. I want to calculate current passing through 8 ohm. What is remaining resistance? That is 12 ohm. So this is opposite resistance divided by addition of resistance, that is 12 plus 8. 12 plus 8 is 20. So just perform the calculation. This answer will be, it is 12 amperes. What about arrow? Look at the diagram. arrow is from LHS to RHS like this, as shown in this diagram. Now step 3. In step 3, what I'm supposed to do, simply add the answers of step 1 and step 2. So in step 3, I will denote this current by IAB, which is I1 plus I2, which is 0.25. In the bracket, be habituate of writing the direction, plus 12. Again, I am writing the direction. But observe these values. These two values are in opposite direction. One is from RHS to LHS, another is from LHS to RHS. In such cases, subtract lower value from higher value. What I said, if the two currents which you are adding are having opposite directions, then subtract it, subtract lower value from higher value. So answer will be 12 minus 0.25, that is 11.75 amperes. What about direction? Give the direction of higher source, that is 12 amperes. So direction will be like this. So that's it for this numerical. Dear students, thanks for attending today's lecture. I have explained you the superposition theorem in much simplified form. If you need more solved numericals, then do let me know in the comment section. Till then, thanks. Thank you a lot.